Hello, I am Nitesh Pradhan from LabVIEW Programming. It is 7th number video of the LabVIEW signal processing series. In this video, we will discuss about the first Fourier transform. I will show you how can we create Fourier transform and we will follow this mathematical modules to generate Fourier transform. In the place of xt, I will take that message signal and then I will use this operator Fourier transform operators and will generate yt is equal to xt cos omega t minus iota xt sin omega t. So let's start designing this concept. Okay, so for that let's start designing the program. Give me a second only. Okay. Open your lab view. In the lab view, come into the block diagram, right click here, come into the signal process, come into the mathematics, elementary, trigonometry, sine and cos. Right click, mathematics, sorry, signal processing. After that, this transform. In this transform, the first one is FFT. Okay. Now, right click, take a for loop. Right click, create constant or control number of sample. After that, cycle, cycle. Right click, take a divide functions. Number of sample divided with the cycle. Okay. Now, right click, come here, take a multiply and multiply this value with the constant 2 pi. So from which platform you can take? From this platform you can take 2 pi constant. Now enter. Right click, take a multiplications, multiply the input value with this iteration value. This one is sine function and one is the cosine functions. You can right click and open the label. Now connect with this, connect with the output of this multiplication functions product. Okay. Now you know very well the output of this for loop will be an array. So it is sin x. Okay. So let's, it is Fourier transform operations. So now I had cos omega t and sin omega t. Come into the mathematics, come into the complex and take this real imaginary to complex functions. Okay. Now it is our FFT. sorry, and this is my complex FFT. Okay, if you want, so you can find the real-time FFT in complex. Okay, right now it is complex FFT has been selected here. Let's come and take one waveform graph and see what will be the output here. Control A, Control U, right click, close. Okay, now right click, come here, take a waveform, run. So I am giving here number sample 100, cycle 1. Let's see. Okay, if sample is 1000 and cycle is 10. Okay, if sample is 128, 8 and sample is 10. Okay, near about 128. There are some mistake which I have did, which I need to clarify, rectify. So that's okay. Sign will go with the, just second, control B. This cos will be real and sine will be imaginary. Now you are getting the perfect, okay, single side FFT. The most real world signal are real valued, and hence you can use the real FFT for the most application. Of course, you could also use the complex FFT by the setting imaginary part of signal to 0. Okay, if I will right click here, FFT size, no, right click. If I will change it, so what will be the output? Now in the real FFT you will get both the spike of the FFT. If you will go with the complex FFT, so in the complex FFT it will be uh, eliminate your imaginary side. So thank you for watching this video. If you like, so please design this FFT concepts. In the next video we'll discuss about the proper FFT, okay, Fourier transform with the real FFT. So thank you.